In this video, we're going to introduce four new mother functions. And the four new mother functions that I want to introduce are the other four trigonometric functions that we've not yet talked about. And they are y equals the tangent of x, y equals the cotangent of x, y equals the secant of x, and y equals the cosecant of x. Now, in order for us to analyze these four graphs, what I intend for us to do is use our basic identities, our fundamental identities, to turn each of these four trigonometric functions into sines and cosines. So for example, the quotient identity for the tangent function lets us know that the tangent of x is equal to the sine of x over the cosine of x. So what I'm going to do is use the knowledge that we had previously gained regarding the behavior of the sine of x and the cosine of x, and try to determine then what will be the tangent of x. So the angles we're going to use will be our five quadrantal angles: 0, pi over 2, pi, 3 pi over 2, and 2 pi. The sine function takes on the values 0, 1, 0, negative 1, and 0 at those five angles. The values of the cosine will be 1, 0, negative 1, 0, and 1. In order to get the tangent of each of these angles, I'll be taking the value of the sine of x and putting it over the cosine of x. So for the first one, this would be 0 divided by 1. That would be 0. For the next one, sine divided by cosine would be 1 over 0, which technically is undefined. However, since we're talking about these things graphically, if you take something that is not 0 and divide it by something that is 0, you are going to wind up with a vertical asymptote on your graph. That's how these things manifest themselves. For the next one, 0 divided by negative 1, that would be equal to 0. And at 3 pi over 2, we would have negative 1 over 0, which again is undefined. That'll show up graphically as a vertical asymptote. And finally, at 2 pi, we'll have 0 divided by 1, which is 0. Now I'm going to be referencing the unit circle angles as we're putting together this graph. So over here, I'm going to put my unit circle so that we can talk about the individual quadrants associated with each of these quantities. Now this is actually going to give us the first two full periods of the tangent function. Here's pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to plot everything that I know from this table. So we will have an x-intercept followed by a vertical asymptote followed by an x-intercept followed by a vertical asymptote followed by an x-intercept. Allegedly, that's enough information for us to figure out what this graph is going to look like. We're going to make it work. So the first thing I want to do is consider the leftmost portion of our graph starting here at x equals 0. When it comes to a vertical asymptote, the only thing that you need to figure out is, will I be going to the top side of the vertical asymptote, or am I going to the bottom side of the vertical asymptote? We can answer that question by heading back to our unit circle with this lovely phrase right here: all students take calculus, or all stale tacos crunch. On this interval from 0 to pi over 2, we would be talking about this portion of the unit circle, all of the angles that are in quadrant 1. So the question becomes, should the tangent be positive through there, or should it be negative? And the answer is, through quadrant 1, all of our angles are positive. Therefore, this should rise toward that vertical asymptote. We're going to try to apply the same logic between pi over 2 and pi. Between pi over 2 and pi, we're talking about angles that are between pi over 2 and pi. That'd be quadrant 2 on the unit circle. And in quadrant 2, the sine is positive, but the cosine is negative, meaning that the tangent between pi over 2 and pi will be negative. As a result, this goes down toward the asymptote on this side. Between pi and 3 pi over 2 will be within quadrant 3 of the unit circle. These angles produce a value of the tangent that is positive. Keeping it nice and smooth and continuous between the asymptotes is going to be important. Finally, between 3 pi over 2 and 2 pi, we would be in quadrant 4 on the unit circle, and the tangent is supposed to be negative through here. Now, through the use of these first two periods, it's relatively straightforward to figure out what the rest of the graph should look like by alternating between vertical asymptotes and x-intercepts. This will also extend in the backwards direction as well. So this will repeat over and over to the left as well as to the right. And I'd like to talk about the aspects of this graph. So things like domain, range, symmetry, x-intercepts, those sorts of things. So domain is going to be all real numbers except for things like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2. We have our first vertical asymptote take place at pi over 2, that should be a pi, and then it occurs every pi units after that in both directions. Once again, we see this occurrence of k, where k represents any integer. The range, which we talked about in section 7.5, will be all real numbers. And indeed, it hits all real numbers between any two consecutive asymptotes. Everywhere that we have a domain issue, we are going to have a vertical asymptote. Vertical asymptote at x is equal to pi over 2 plus k pi. We'll see x-intercepts at every integer multiple of pi. Additionally, between two consecutive asymptotes, the graph is smooth, continuous, and increasing. Between any two consecutive asymptotes, the graph is smooth, continuous, and increasing. Please feel free to reach out to any sort of graphing software like Desmos if you're interested in seeing a much cleaner version of what I have drawn here. All right. Now that we've done this with the tangent of x, we're going to repeat this process with the cotangent of x. So like we did for the tangent, first thing to do is to express this in terms of the sine and the cosine. The cotangent will be the reciprocal of the tangent. So as we did before, we'll select our quadrantal angles for x, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine of x will take on the values, same as they did before. Cosine will take on the values 1, 0, negative 1, 0, and 1. So the cotangent of x is going to be equal to the value of the cosine divided by the value of the sine. At x equals 0, this would be 1 divided by 0. 1 divided by 0 is undefined, and just like the tangent, it is going to show up as a vertical asymptote. At pi over 2, we would have 0 divided by 1. 0 divided by 1 is not undefined, it is in fact 0. At pi, we would have negative 1 divided by 0, which is undefined. Therefore, we'll see a vertical asymptote appear. At 3 pi over 2, 0 divided by negative 1, that'll be 0. And finally, at 2 pi, we see the same thing as we did at x equals 0, which is 1 divided by 0, which is undefined, which manifests as a vertical asymptote. As we did for the tangent, we'll be referencing some angles on the unit circle to come up with as accurate a graph as possible. So we'll start marking off our quadrantal angles on the x-axis. Now this one's going to be a little bit different because it starts with a vertical asymptote this time. We'll also see a vertical asymptote at pi. And we'll see a vertical asymptote at 2 pi with x-intercepts at pi over 2 and 3 pi over 2. Now we're going to treat this similarly to what we did for the graph of the tangent function by simply posing in each of these quadrants for the angles, should the cotangent be positive or should it be negative? Now once again for quadrant 1 it should be positive, and for quadrant 3 it should be positive. Which means that between 0 and pi over 2 I would expect this to be on the positive side of things. Whereas between pi over 2 and pi, quadrant 2 angles, cotangent would be negative. So we get for all intents and purposes the same shape of the graph as what we got for the tangent. It'll just be decreasing rather than increasing. This is easy to replicate for future periods. Next vertical asymptote will be at 3 pi, and also in the reverse direction. First vertical asymptote on the negative side would be at negative pi. So this is your shape that's going to repeat over and over indefinitely, both to the left as well as to the right. The domain will be all real numbers except for x is any multiple of pi. 0 pi, 1 pi, 2 pi, 3 pi, negative pi. That's where we get those vertical asymptotes in. The range, as you can see, between any two vertical asymptotes will be all real numbers. We will see vertical asymptotes everywhere that we have a domain issue. So that'll be x equals k pi. There will be x-intercepts at x equals. First one occurs at pi over 2, and then it occurs every pi units after that. And then between consecutive asymptotes, the graph is smooth, continuous, and unlike the tangent, the cotangent is decreasing. Now the other thing to mention that's true for both the tangent of x as well as the cotangent of x, so both y equals the tangent of x and y equals the cotangent of x, we should point out that 1 period would be the distance between any two consecutive asymptotes. And for both the tangent as well as the cotangent, that period happens to be pi. Now, in comparison to the graphs of the sine and the cosine, which had things like a midline, or an amplitude, or a period, really it's only period that applies to this. However, there are not a lot of real-world quantities that over a fixed time interval tend to go from a positive infinity to a negative infinity, or a negative infinity to a positive infinity. So, unfortunately, the graphs of the tangent and cotangent don't have a lot of real-world applications. So we're not going to do a whole lot with them. Yay!